Hello everybody! I hope everyone's having a wonderful day. So today we're going to be proving that f of n, which is going to be equal to 2n plus sine n plus 5 is big O of n squared. Now, I want to make sure I walk through this one carefully with you because I want to make sure we get through all the tips and tricks, things that mathematicians, computer scientists that really like these kind of proofs. You want to make sure we hit all the points that really matter here. So the first thing I'd recommend is if you're trying to prove a statement like this, don't ever write down the definition. They will just assume that you know exactly what's going on in their heads too. So when you're reading and writing these kind of things, just say what you want to say anyway. So just instead of talking about what the definition is, just start immediately. Just go right into it. Don't want to waste the time of the viewer. So what you might want to say is something like, let's show f of n is big O of n squared. So the first thing I would probably do is I would just straight up, like, heck, you don't even need this. This you don't even need. In fact, let's just scrap the whole definition together. Let's just start throwing them together into the names here. We don't want to waste the time of the viewer or reader. So what we're going to do is we're just going to immediately just select, we're going to pick something. We're going to pick C is equal to, let's think about this. 2, I don't know, like, it doesn't have to be super clear to everybody. It's just the point is that it has to be correct. You don't have to ever justify these things in a proof. It's just, as long as it works, okay? They can take your word for it, okay? So I don't know, I'll pick like, let's pick like 8. Let's go with 8. Then, what am I going to do? Well, why should I write that? Why should I write that? That's just going to waste the time. We don't want to explain everything to everybody, okay? We're going to pick C is equal to 8. Then, well, I don't know, let's just start writing some inequalities, do some algebra. So, I don't know, like 2n plus sine n plus 5. This, I don't know, it's like less than or equal to 2n plus, okay, well, sine can either go up or down. It goes like this, right? That's obvious. It's all obvious. This is all obvious for us, by the way. Actually, let me put that in here. So then it is obvious that 2n plus sine n plus 5 is less than or equal to 2n plus 1 plus 5, which this is in fact going to be equal to 2n plus 6, which, I don't know, I think it's kind of clear that this, if I take this and I rewrite this sort of like this, 2n squared plus 6n squared, you'd agree with me that this is 8n squared, right? And I'll just say this is clear. Right? That's just obvious, right? In fact, maybe I should insert some more words in here just to really kind of make this sound more sophisticated, as opposed to just trying to justify things to you without like boring you. Because boring proofs aren't fun, okay? At least with mathematicians. Mathematicians, they just love it when everybody uses the word obvious and clear. Clearly, obvious, that there's no difference. There's no difference between that and specifying things. Like, I don't even know, like, I don't even write down what the domain of this thing actually holds for. I don't know, like I do know, actually. I should be a little bit more clear. I do actually know, but I don't need to write it down for you, okay? It's clear. Remember, we've established it's just clear. Okay, so now I have that. Okay, now, like what should I pick for n0? Like, okay, then I'm going to choose n0. What should n0 be? Okay, so if I know, so when do I know this is true? Well, I know it's at its largest when it's 1, right? So it becomes 1 at its largest. So I know that this always has to be true. This always has to be true. It's just clear. So I'm just going to pick it to be 1. Do I even need a conclusion? I don't know. I don't know. It just doesn't feel right. I think this is the perfect way to end this proof. I think it's wonderful. So, just walking you through. So, here's the game plan. You don't write any details down. Remember, you don't want to waste the time of the reader. Just simply say what you're going to say. Like I said, just keep it. Remember, it's just obvious. This is all just obvious and easy to do. Somebody on the internet told me so. So what you do is you pick C, and then I pick C. Now, you might naturally ask, where the heck did C come from? Okay, you notice that this is C right here? It's just clear. It's obvious. So there's C right there, if you're wondering where C went. Okay? So it's a piece of cake. So you just say that it's C, and you pick N0. There's no need for any, there's no middle stuff. I did all the meat and potatoes here. You might naturally ask, well, when is this true? Like, for what values of n? I mean, it's just obvious, right? So this is a wonderful example. So notice that we could just prove this claim like this. Remember, just don't waste the time of the reader. It's very easy to just simply write it down without any context or quantifiers or anything like that. It's just algebra, right? So I want to say thank you very much and have yourself a beautiful day. I'll see you later.